Hello everyone, welcome to my channel oneconceptelectrical. This is one of the DC machine question. Mainly the concept in this particular question is speed control. Speed control of DC machine by adding an external resistance in series with an armature circuit. Before solving this question, let's write down the data. Here it is given it is DC shunt motor is running at a speed of 750 rpm and its terminal voltage is 250 volts and it's taking a full load line current. Underline this concept, it is in line current of 60 amps. In armature resistance is zero point 0.4 ohm and field resistance is 125 ohm. And the given brush voltage drop of 2 volts. There are three questions in this particular one. Let's solve one by one. In first question, they are asking to find no load speed for no load line current of 6 amps. Here, let's write down the data. It is under loaded condition, its speed is under 750 rpm and terminal voltage at 250 volts and line current of 60 amps, armature resistance of zero point 0.4 ohm, field resistance of 125 ohm, and brush drop of 2 volts. It is drawing a line current of 60 amps. We already know the field current IF equal to VT by RF. It is 250 by 125, it will be 2 amps. By simple KCL, IL equal to IA plus IF, armature current IA equal to IL minus IF. Then 60 minus 2, it will be 58 amps. Means armature current will be 58 amps. By this, under full load condition, the back EMF VB equal to VT minus IARA. By substituting the above values, I got a back EMF of 226.8 volts at a speed of 750 rpm. 750 rpm, right? They're asking to find no load speed for no load line current of 6 amps. Here, the field resistance is 125 ohm only. Means VT by RF. IF equal to VT by RF. It is a constant quantity of 2 amps. By simple KCL, here the armature current will be 6 minus 2. It will be 4 amps. Then the back EMF VB equal to VT minus IARA. Here IA is a 4 amps. Then the back EMF under no load condition is 284.4 volts. In the full load condition, in the above case and this case, flux is constant, means IF is constant. IF is of 2 amps only. Then back EMF EB1 by EB2 equal to phi 1 by phi 2 into N1 by N2. N1 is 750 rpm, means under full load speed. EB1 back EMF of motor under full load condition. EB2 back EMF of motor under no load condition. Both flux is constant, means phi 1 phi 2 cancels each other. N1 speed of motor under full load condition. N1 is 750 rpm. By this, no load speed of shunt motor is 821 rpm. Approximately it will be 822 rpm. Means the first question, no load speed for no load line current of 6 is 822 rpm. Now they are asking under full load condition, if you add external resistance in series with an armature so that the speed will drop to 600 rpm. Means we are modifying some circuit. Like by adding an external resistance in series with an armature, the speed should drop to 600 rpm. Under full load condition, we already know the load current is 60 amps. They are already given in the data. The field current is constant. Means RF is 125 ohm. Then VT by RF. IF is equal to 2 amps only. Means flux is constant. Under this condition, we already know how to find a back EMF. We need to find back EMF. If we use the formula EB3 equal to VT minus IA into RA plus R external, in this condition, there is two unknown parameters here. Unknown parameters are EB3 and R external. In order to find R external, first we need to find EB3. For this, we are using the formula EB equal to K into phi into omega. Here, EB1 back EMF of motor under full load condition means at the rate of 750 rpm, means this voltage is 226.8 volts. EB2, EB3 means in this particular condition, back EMF. We need to find this one. Flux 5 and 5 to constant because in the both the conditions field current of 2 amps only. Here N1 means 750 rpm. In the first case it is 750 rpm. N2 means N3 it will be 600 rpm, means this rpm. By this, in this particular, by adding external resistance, the back EMF will be 181.44 volts. Now by using this formula, I am finding R external. Here the R external is 0.782 ohm. Means under full load condition, if machine running at 750 rpm, if you add external resistance R external of 782 ohms, the speed will reach to 600 rpm. Right? Means if you add an R external of 0.782, the speed will reach to 600 rpm. In the third question, they are asking to find percentage reduction in flux per pole needed in order that speed may be 900 rpm when armature current of 30 amps. Means no resistance in the armature. They are doing some another modification here. Instead of adding R external in the series of armature circuit, they are reducing the flux per pole. Here you see the field resistance is constant. Means IF3 will be Vt by RSH. It will be 2 amps. This is constant. Means flux is constant. No. Here flux is not constant. Here in this question they are asking to find we need to reduce flux per pole. Okay. First we need to find back EMF. Back EMF EB, here EB equal to 250 minus 30 into RA, means 250 minus 12. It will be 238 volts. Here 226.8 volt is at the speed of 750 rpm. Means in the first case. Here in the first case here. EB3 is this condition voltage. Speed is in first case 750 rpm. There are now it's going to speed of 900 rpm. Means 53 by 51 will be 0.7844. Percentage reduction means 53 minus 51 by 51 into 100. The percentage reduction is 12.5%. Means if armature current of 30 amps, if you manage to reduce the flux by 12.5%, the speed will reach to 900 rpm. Right? This is a very lengthy question. Mainly these sort of questions will be in IES mains or any theoretical examinations. For this sort of question, please subscribe to my channel.